Hi, this is a simple LED chaser circuit, and this is for my DLD course for CHOWDHURY AKRAM sensor. I will just go straight to the component list where I have used 555 timer and a 4017 decade counter, and we have also used 10 LEDs, a trim pot which is basically a potentiometer, and we have also used 4.7 kilo ohm resistance over here, and also a capacitor which is rated as 10 microfarads, and we are also gonna need a 9-volt battery, also a breadboard. Let's now go to the pinouts of the 555 timer IC. Here we will just use the 8th pin of the 555 timer IC to the positive terminal of the breadboard, and we will use a wire to connect the first pin to the negative terminal of the breadboard, and then we will short out the 8th pin to the 6th pin, and also we are gonna short out the 2nd pin to the 7th pin. Sorry, we are gonna connect the second pin to the 6th pin over here, and we're gonna short it out. Here we are also connecting the 10 microfarad capacitor, which will be like the first pin will consist of the negative side of the capacitor, and the second pin will have the positive lead of the capacitor. And here on the 7th and 8th pin we have used a 4.7 kilo ohm resistance, and here we can use a resistor or a trim pot in this case, and we will connect it to the 7th and 6th pin of the 55 timer IC. Now we will place the 4017 decade counter on the breadboard with its indented side facing the left side. So here we will actually use the 16th pin, and we will directly connect it to the power source or VCC, and we will use the 8th pin to the ground. Now we will use two connectors or wires to short out the pin 15th and 13th to pin number 8. Now we will connect a wire from the 555 timer IC to the 4017 decade counter. Here we will use the pin 3 of the 555 timer IC and the pin number 14 of the 4017 IC. We will also use a resistor of 4.7 kilo ohm. Here we will use it on the negative terminal of the breadboard. Here we can see we have inserted one lead in the negative terminal, and we have also entered another lead on the negative terminal of the breadboard, where we will also connect the negative leads of the LEDs over here. Now we will connect the wires from the 4017 IC to the LEDs. So we will at first connect the 3rd pin to the first LED and the 2nd pin to the 2nd LED. We will connect the 4th pin with the 3rd LED, 7 with the 7th. We will use the 10th with the 5th LED, 1 to the 6th, and sorry about that, let me just correct that. And we will start from the beginning. We will connect the 3rd pin of the 4017 decade counter to the 1st LED, 2nd to the 2nd LED, 4th to the 3rd LED, the 7th to the 4th LED, and 10th to the 5th. The 1st pin will go to the 6th LED, the 5th pin will go to the 7th LED, and the 6th pin will go to the 8th LED. and also 9th pin will go to the 9th LED, and finally we will use the 11th pin for the 10th LED. Now I will just connect the power of my battery to the positive rail of the breadboard. And here we can see the LEDs are flashing here. Now let me just explain how the circuit is working here. Basically the 555 timer IC is configured to work in an S-stable mode, which means the output from the 555 timer changes continuously from high to low. And in other words, we can say if we connect a LED between the output of the 555 timer and the ground, then we will see the LED or LED blinks or flashes continuously. And this pulse from the 555 timer will go straight to the 4017 IC, which is a decade counter basically, and it has 10 outputs. And we have talked about the 10 output pins already. Like we have already connected the LEDs to the 10 outputs of the 4017 IC. And by default the first output pin is on high and the rest are usually off, and each time the clock input pin of 4017, which is the 14th, it detects a rise in voltage from high to low, it turns off the current output and turns the next sequential output. This swapping of output, which looks like the LEDs are chasing each other, will continue until the last LED, and it will keep on doing it as long as we don't remove the power from the breadboard. Finally, I'd like to show you the use of this trim pot here. We can adjust the timing of these LEDs. We can slow it down or we can make it go faster by just adjusting this trim pot. Here I'll try to reduce the speed over here, and here you can see the LEDs have slowed down already. And if you want to revert it back to its normal pace, then you just have to rotate the trim pot over here. So that's basically it. If you have any questions, you can comment down below, and I'll try my best to answer your questions. Thank you.